Good morning, sir.
Am I audible perfectly?
Yes, sir.
Okay. Shall we start? Hello.
Yes, sir.
Okay. Now we are shifting to a new method named list squares method. In this method, you have already used it once. If you can recall, the regression analysis in the last semester, you did the same thing. List squares method. As the name suggests, the square should be list. List means the smallest one, right? So the square should be list. That method is called, or a method in which you try to make that sum of the squares list. List means a minimum. That line, the line which you are getting, is called a best fitted line. In a regression analysis, all of you have used it many a times. Whenever you were getting a regression line, there were an option of many regression lines, of which you were getting only one out of it. How you were getting it? You were trying to get the best fitted line among all those lines. To get this best fitted line, we try to use a method, and that method was method of least square. Now, what exactly this method of least square is, and why we need to get the best fitted line. Till now, whatever we have done, we try to get the moving averages. It was 3 yearly, 4 yearly, 5 yearly, 7 yearly, and so on. Means whatever data was given to you, you were trying to observe it. And there was a sort of a limitation in that case that you couldn't predict the future. Predict the future in the sense, again, it was little haphazard. By graphical method, you can predict the future. For a moment, let us suppose data set of 2001 to 2010 is given, and our interest is to predict the value for 2012. Let us suppose data set of 2001 to 2010 is given to you, and our interest is to get value of 2012 to predict the future. Or for a moment, let us suppose data set is given to you from 2010 to 2020. And our intention is what may happen in 2022 if the normal circumstances remain same. At that point of time, you have to establish a model. A model is to be established in the sense it should be somewhat in an equational form. To get an equational form of it, naturally, you have to assume something. Generally, the initial period, you can assume that your variables are linearly related, as you were assuming it with regression lines. In a regression line type of a data, always you are assuming that the relationship between two variables are linear. Similarly, here in a least square method, we are going to use two different assumptions. One is linear and second is non-linear, or you can say parabolic. First of all, let us concentrate on this part. Least square method gives you an equation. This equation is very much needed And once you get this equational part, then it is very easy for us to predict the future if the circumstances remains same. Right? Okay. What this method of least square is? This least square method gives, we are trying to get that particular equation. How? The base or the basic of this least square method is, there are 2 points. One is y summation of, means sum of deviations of the actual values of y and the computed trend, means y calculated, is 0. That becomes the first thing, the first condition. And the second condition here is that sum of the deviation of y minus yc, you may have done it. We have already calculated this short-term fluctuation, and you might have marked it that the short-term fluctuations are, some of the entities are positive and some of the entities are negative. To make all of them positive, the simple thing is to be done is to make it a square. Once you make a square, then if you just make a sum of each of them, ultimately that sum should be the least one, the lowest one. If these two conditions are satisfied, then you can say that the line which you are getting is the best fitted line. And that is what our intention is, to get this line which is a line of best fit. Okay. When I say that we are assuming a linear relationship, whenever a linear relationship is there, then you can assume that what should be the equation? What should be the equation? Can anyone say a general, or you can say a very common equation of a line? Can anyone throw any light the generalized format of a line, or you can say a linear equation? What is the standard form of a linear equation? I am asking you just because of you have already done it. You have already passed through it in a regression analysis. Can anyone throw some light on a linear equation? Any linear equation. Can you give any example of a linear equation? Yes, Vijayata. Yes, Vijayata.
ax plus by is equal to c.
Okay. I am putting it in a different way. Y is equal to a plus bx. Can it be a general form of a linear equation? Y is equal to a plus bx is a general form of a linear equation, where your y, in our case, in this particular case, your y is a trend value, your x is unit of time, a is the y-intercept, and b is a slope of line. Okay, that simply indicates that if you just substitute value of a and b in this equation, it forms a linear equation. For a moment, let us suppose your value of A is 2 and value of B is 3, then Y is equal to 2 plus 3 times X. that becomes an example of a linear equation. Is it so? So our intention with this example is to get value of A and B using the behavior of variables. The data set whichever given to you, if you just try to get value of A and B out of that, and if you just substitute it in an equation y is equal to A plus bx, then you will be able to get a linear equation. Now what that linear equation is? That linear equation shows that how your value of x and value of y are relating. This becomes a model of the relationship between x and y. Now, left hand side it is y and right hand side it is x. So, x is independent, whereas y is dependent on x, and that is what exactly happens with a trend value. Always your trend values are dependent on time. So this becomes the best linear equation, right? So a generalized linear equation is y is equal to a plus bx. Now, our challenge is to get value of a and b using the data set given to you. How you will be able to get value of a and b? For that, certain processes there, and we take method of least square to get this value of a and b. From the generalized equation y is equal to a plus bx, do one thing. First of all, just try to implement summation both the sides. So y is equal to, I think all of you are having pen and paper with you. Just try to understand it so there would not be any issue. If these basics are clear, then you will not find any difficulty in any of the examples. And you don't have to mug it up any of the formulas. The things are very simple. As I said it, if a method of least square is to be used and you assume that x and y variables are linearly related, then the standard form of an equation is y is equal to a plus bx. In this equation, intention is to get value of a and b. To get value of a and b, we have to use the data set. The data set, whatever it is given to you, if we can fetch value of a and b out of it, if you just substitute it in this equation, it becomes a linear equation, and you can state, you can claim that your variable x and y are related with the given or the thing which you have found, that model, that linear model. Okay, now the process is the idea of getting value of a and b. How one can do it? In that case, certain mathematical processes are to be done. First, there are two methods in it. One of the method is called direct method and second method is called a shortcut method. Initially, we try to understand it with a direct method. In this direct method case, things are very simple. You don't have to mug up anything out of it. Just try to write down. If you have pen and paper with you, just write down the standard form of a linear equation. Y is equal to a plus bx. Have you written it? I think we are running short with time. Be little responsive and try to respond it as soon as you understand it.
Yes, sir.
Okay. First of all, just write down on the paper y is equal to a plus bx, which is a standard form of a linear equation. Perfectly okay?
Yes, sir.
Okay. Do one thing now. Just substitute, or you can say just apply summation both the side. Both the side of the equation means left hand side of equal to as well as right hand side of equal to. What will happen then? Apply summation both the side. So left hand side it would be summation of y, which is equal to summation of a plus bx in a bracket. Can I write it that way?
Yes, sir.
Okay. Once you write down summation of inner bracket a plus bx, that can be expanded. You can make it individualized. So the next would be summation of a plus summation of bx. Is it so? So summation of y is equal to summation of a plus summation of bx. Can you put it that way?
Yes, sir.
Okay. Once you put it that way, then again more simplification, summation of y, which is equal to a is a constant value. So you can take it outside of the summation sign. So it would be a summation of 1. Once you take a outside, it becomes summation of 1 plus b is again a constant value which you can take it outside of the summation. So it becomes b times summation of x. Is it so?
Sir, I'm not getting that point.
Okay. Is there any problem within this? Are you, as I said it, use pen and paper. In a mind, you may not be able to do it. First thing first, y is equal to a plus bx is a standard form of a linear equation. Just apply summation both the side. While applying summation both the side, this equation comes to summation of y, which is equal to summation of inner bracket a plus bx. Is it so?
Yes, sir.
Okay. Naturally, right hand side it is summation of a plus bx. So naturally that summation is to be applied to both the cases. Means that open that bracket itself. While opening that bracket, right hand side it would be summation of a plus summation of bx. Is it so?
Yes, sir.
Okay. As you know that the summation applies only on variables, it may not get affected. Means constant values are not being affected in that case. So constant values you can take it outside of your summation. So further simplifying it, it comes to summation of a can be taken out. Means it would be a times summation of 1 plus b times summation of x. Is it so?
Okay, sir.
Right. Okay. Summation of 1. What do you mean by that? There are n observation and summation of 1 means 1 plus 1 plus 1 plus 1 plus 1. How many times plus 1 is there? If n observations are there, then naturally it would be, means summation of 1 is nothing but your n.
Yes, sir.
So your equation becomes summation of y, summation of y, which is equal to summation of 1 is n times a plus b times summation of x. Is it so? So that becomes
Yes,
our
sir.
first equation. That becomes our first equation. Okay, how you found this first equation? You have simply applied summation both the side in a standard form of a linear equation. Is it perfect?
Yes, sir.
Okay. Now, to get a second equation, apply summation of x both the side in a standard form of a linear equation. In a standard form of a linear equation, apply summation of x both the side. What is going to happen now? Y is equal to a plus bx. Apply summation of x both the side. So this equation will be transferred to summation of xy, which is equal to a times summation of x plus b times summation of x square. X is already there. We are applying one more summation of x in that case. That is why it comes to summation of x square. Is it clear?
Yes, sir.
So one thing is very clear, that to get the first equation, we are applying summation both the side, and to get the second equation, we are applying summation of x both the side, right?
Yes, sir.
Okay. Once you get this two equation, now summation of y. Now just observe summation of y, which you can get it from a data. N is number of observation which you will be able to get it from a data set. Summation of x, which you can get it from the data. Summation of xy can be found from the data. Summation of x can be found from the data. And summation of x square can be found from the data. That means if you just try to substitute all these values, then you will be able to generate two different equations of variable a and b. And if you make a solution of this two equation, you will be able to get value of a and b. That is nothing but a solution of two linear equation. Once you get a solution of this two linear equation, you will get value of a and b. That value of a and b can be substituted in a standard form of a linear equation, and that is how you will be able to get the equation, the linear equation by which your two variables are associated, right? Okay, so these are the two equations, right? Okay, let us shift to the next. Now, there are two methods. One is direct method and second is shortcut method. Right now, we are concentrating it on a direct method. Let us take one of the examples that will make it clear how to do it. Right? Just write down the example. Fit a straight line trend by the method of least squares by taking 2001 as a year of origin for the following data. The data set given to you are in a form of 2002, 2003, 2004, 5, 6 and 7 with a production in lakh ton. Okay. First of all, try to understand the example itself. Example asks you to fit a straight line. Means linear equation is the best thing using method of least square. And the third instruction given here is origin should be 2001. Fine enough. First of all, make two columns. The first column is year and second column is production. Just count down how many elements, how many year data is given to you. 2001 is an origin. So 2002, 3, 4, 5, 6 and 7. 6 set of data is given to you. So your value of n becomes 6. Is it perfect?
Yes,
Yes,
sir.
sir.
Okay. Second thing, the production is given to you. Your year is always on an x-axis, that means it is your x, right? Okay. The production is y. Production means the data set which is given to you, which is always you are taking it in a graphical method, you are taking it on a graph paper as y-axis. So that becomes your y. Okay. Put it in a column. So that, and make a sum of that column. 5 plus 7 plus 9 plus 10 plus 12 plus 17. If you just make a sum of each of them, it comes to summation of y, which is equal to 60. Are you getting it? Just confirm it.
Yes, sir.
Yes, sir.
Okay. Once you are through about this, now what try to focus on, uh, as they said it, that 2001 is a year of origin. Naturally, the given data, all the years, is to be deducted from origin. So 2002 minus 2001 means deviation from 2001. Whatever is the origin, that is to be deducted from the year given to you. In this case, it was specifically given that you have to take a deviation from 2001. So 2002 minus 2001 comes to 1. So make another column as deviation from 2001, and that becomes our new variable x. So make a column of variable x now. 2002 minus 2001 is 1. Similarly, 2003, Urvashi, your audio is disturbing each of us. 2003 minus 2001, the value remains is 2, so you have to put a value 2 in the column of x against 2003. 2004 minus 2001, the value comes to 3 and you have to put 3 against 2004. Is it clear? This is how you
Yes,
are
sir.
supposed to build column number 3. Naturally, each of them are at a distance of 1. So 1, 2, 3, 4, 5 and 6. These are the values which you are getting. And if you make a sum of each of them, ultimately what you might get would be 21. So summation of x is 21. Is it perfect?
Yes, sir.
Yes,
Are
sir.
you getting, all of you are getting this 21?
Yes, sir.
Yes,
Okay.
sir.
The next column would be x multiplied by y. Now you have both values. One of the column is x and one of the column is y. Whatever are the entities among this column, make a product of those two and put it in a column of x, y. X multiplied by y. So 1 multiplied by 5 comes to 5. So you have to put 5 against 2002. 7 multiplied by 2 comes to 14, which you are likely to write against 2003. 9 multiplied by 3 comes to 27 against 2004. 10 multiplied by 4 comes to 40 against 2005. 12 multiplied by 5 is 60, write it against 2006. 17 multiplied by 6 is 102 and write it against 2007. So all the elements in the column x multiplied by y is written off. At the end, write down summation of xy. Summation of xy means sum of each of these entities. To write down sum of these entities means it is 5 plus 14 plus 27 plus 40 plus 60 plus 102, and that sum is 248. All of you are getting this 248.
Yes, sir.
Sir.
Okay,
Yes, sir.
right enough. Okay. The next column is sum x square. X square means whatever there in the column of x is, make it square. The column x is 1, 2, 3, 4, 5, 6. So all the entities are to be squared off. 1 square, which is 1, 2 square, which is 4, 3 square, which is 9, 4 square, which is 16, 5 square, which is 25, and 6 square, which is 36. And this is how a column of x square can be built up. Right enough? If you make a sum of each of them, it's 1 plus 4 plus 9 plus 16 plus 25 plus 36. That sum comes to 91.
91.
Are you getting 91?
Yes, sir.
Okay. Now, do you feel what are the columns needed? First thing first, which are the columns required? Just come back to both the equational part. When you were using method of linear equation or method of least square, at that time you found two equations, right? I'm coming back to that part. Summation of y, which is equal to n times a plus b times summation of x, right? The second equation was summation of xy, which is equal to a times summation x plus b times summation of x square. Okay. Apart from A and B, just list down what are the things. Apart from A and B, what are the things? The first thing is summation of y. Just list it down on paper. That will make you a very clear thing. The first thing is summation of y. Second is n. Third is summation of x. Next is summation of xy. Next is summation of x and summation of x square. This many things are required from a data set, right enough? While you observe the equational part, what are the things required? So these are the 6 different entities which you require to get it solved. Okay. So naturally, just observe now what we did here. Look, in this case, value of n is 6, summation of x is 21, summation of y is 60, summation of xy is 248, and summation of x square is 91. Means you could get almost everything.
Yes, sir.
Sure.
Okay. Now, substitute all these values in an equation. While substituting it in the equations where summation of y is equal to n times a plus b times summation of x. So as you have calculated, summation of y is 60. So 60 is equal to 6 times a plus 21 times b becomes our first equation.
Yes.
Okay. Similarly, summation of xy is a times summation of x plus b times summation of x square. Summation of xy is 248. Summation of x is 21. Summation of x square is 91. So the second equation comes to 248, which is equal to 21 times a plus 91 times b, and that generates a second equation.
Yes, sir.
So once you generate these two equations, now things are very simple. In a routine form, just get it solved. I am assuming that you know the solution of two linear equation quite well. How one can get it solved? Let us suppose these two equations are given to you. In this case, variables are a and b. How you will be able to solve it? આને solve કઈ રીતે કરી શકાય? Anyone?
Compare, comparing both the equations.
How you will be comparing it? Naturally, to get a solution of two linear equation is eliminating one of the variable and getting a value of another. Once you get a value of another, substituting it in that equation, you will get variable 1, the first variable. Okay. Now, to eliminate one of the variable, naturally, the coefficient of variable should be same. Coefficient of variable means whatever number before the variable is. In this, in the first equation, the variable is a and coefficient is 6. In the second variable, in the second equation, variable is a and coefficient is 21. Right enough? Okay. I am assuming that you know how to solve two linear equations. In any case, if you don't know, then we'll see it in a length. Can I expect that you know how to solve two linear equations?
Yes, sir.
Yes, sir.
Probably you might have done it with the regression analysis and even at a school level. Okay, now these two linear equations, if you just solve it, to get it solved, naturally coefficient should be same enough. So to make this coefficient same, first equation is multiplied by 7 and second equation is being multiplied with 2 to make coefficient of A same. 6 and 21. 6 means it is 3 multiplied by 2 and 21 is 3 multiplied by 7. 3 is common, so 7 and 2. So first equation is being multiplied by 7 and the second equation is being multiplied by 2. Okay, both the side you have to multiply it. So both the side, it is 60 multiplied by 7, that comes to 420, which is equal to 6 multiplied by 7 means it is 42a plus 21 multiplied by 7 is 147 times b. In the second equation, both the side you have to multiply it with 2. So 248 multiplied by 2 comes to 496. 21 multiplied by 2 comes to 42a and 91 multiplied by 2 comes to 182 times b. Is it so? You are writing it again simply the first equation multiplied by 7 and the second equation multiplied by 2. Right enough? Okay, now put a negative sign in between of them. Hence what you are likely to do is making a deduction. So 420 minus 496 comes to minus 76. 42a minus 42a, that goes off. That means it is an elimination. Variable a is being eliminated. Fine enough. 147b minus 182b comes to minus 35b. Is it perfect?
Yes, sir.
So your value of b is minus 76 upon minus 35. Minus minus becomes plus, and value of b becomes 2.17. Every one of you, are you getting value of b as 2.17?
Yes, sir.
Yes.
Okay. Now, in any one of these two equations, if you just substitute value 2.17 as b, you will get value of a. For a moment, 60, I'm concentrating on the first equation. 60 is equal to 6 times a plus 21 times b. Now substitute value of b as 2.17 in that equation. So 60 is equal to 6 times a plus 21 times 2.17. Simplifying it, 6 times a becomes 14.43. So value of a becomes 14.43 divided by 6. 14.43 divided by 6 comes to 2.40. Are you getting this value?
Yes, sir.
Okay. Now you could get value of a and value of b using this method of least square. Substitute these values of a and b in a standard form of a linear equation where you started it from. So y is equal to a plus bx was the standard form of a linear equation in which you have to substitute this value. So y is equal to value of a. What is the value of a?
2.40.
2.40.
2.4 plus value of b. Value of b is
2.17.
2.17 times x, and
17.
2.17 times x, and this becomes a linear equation by which your value of x and y are modeled, or x and y are related. Whenever you write down this linear equation, you have to put all the other clarification. With this equation, your origin was 2001. Your x unit, if you just put it on a graph paper, what was your x unit? It is differences of 1 year. So x unit is 1 year. With all these three informations, you have to write it off. First, a linear equation. Second is origin. And the third thing is x unit. You have to specify all these three parts. Right enough?
Yes, sir.
Now, the final thing. Final calculation. Our intention was to get trend values. Now, coming back to your tabulated part, again on a table. For 2002, your value of x was 1. Just observe your table. While you are observing your table, against 2002, your value of x was 1 because you took a deviation from 2001. 2002 minus 2001, so value of x is equal to 1. X was 1. Just try to observe that column which you made right away. Okay. So to get a trend value of 2002, Just substitute value of x as 1 in the trend equation. Your trend equation is y is equal to 2.4 plus 2.17 times x. If you just substitute x is equal to 1, you will get a trend value for 2002. Okay. 2.17 multiplied by 1 is 2.17. 2.40 plus 2.17 comes to 4.57. All of you are getting this 4.57?
Yes, sir.
That becomes the trend value for 2002. So just try to insert one more column in that table against 2002. Make a column of trend values YC. Make a column and title of that column is YC. Means Y calculated. That becomes a trend value. Against 2002, which is y is equal to 2.40 plus 2.17 in a bracket 1, simplified it comes to 4.57. So 4.57 will be the first entity in that column. What should be the next? For 2003, your value of x is 2. So substitute value of x as 2 in the in this trend equation. So y is equal to 2.40 plus 2.17, multiply it with 2. 2.17 multiplied by 2 becomes 4.34 plus 2.40, and that total comes to 6.74. Now this 6.74 is to be written in a column against 2003. Do the same thing for 2004, 2005, 2006 and 2007. And make sure that you are getting the values which are shown here. Calculate it for 2004. What are the values which you are getting? Are you getting 8.91?
Yes, sir.
Okay. Try to get value for 2005 now.
11.08.
11.08 is the value which you are getting it for 2005. Similarly, try to get value for 2006.
13.25.
Perfectly okay. For 2007.
15.42.
15.42.
15.42, right? And all these values are to be written on that table, the table which you already designed. This was the column year, production, deviation, xy, x square, and a new column will be yc. And that is where you have to write all these values: 4.57, 6.74, 8.91, 11.08, 13.25, and 15.42. Is it perfect?
Yes.
Any question about this? Anything which you are not getting in this part?
Hello, sir.
Yes.
We have to take the square of x at every sum. Is it so?
Square of
X.
summation of x square is required. Summation of x square is required, so you have to make a square of x as a column format, in a column form. So naturally you have to, because ultimately your intention is to get sum of x square, means whatever are the values of x square, that is to be summed up. So naturally you have to calculate it. It is very much needed.
Okay, sir.
I'm trying to summing it up. I'm trying to conclude this thing, right? Let us do it this way. If you want to write it down, you can write it down, because this becomes how, or you can say this becomes a skeleton. Okay. In a method of least square, if a linear equation is assumed, so that linear equation, standard form of a linear equation, y is equal to a plus bx, which is a standard form. We are running short with time. Please respond.
Yes, sir.
Okay. Standard form of y is equal to a plus bx. To get value of a and b is our prime challenge. To get this value of a and b, naturally certain equations are to be formed. So first thing is to be done is apply summation both the side. When you apply summation both the side, first equation comes to summation of y, which is n times a plus b times summation of x. That becomes our first equation.
Yes, sir.
Okay. This, to get a second equation, apply summation of x both the side in a standard form. In a standard form of a linear equation, if you apply summation of x both the side, the second equation comes to summation of xy, which is a times summation x plus b times summation of x square. Is it perfect?
Yes, sir.
Okay. Once you get some equation number 1 and equation number 2, from which you will be able to get what are the columns required. Okay, summation of y is required, n is required, summation of x is required, summation of xy is required, summation of x is required, and summation of x square is required. Is it perfect? So this many different columns are to be formed. For sure, the data set given to you, you have to formulate this. You have to formulate the columns from which you can get summation of y, n, summation of x, summation of xy, summation of x we already found it, and summation of x square. Is it perfect?
Yes, sir.
Okay. So this many columns are to be designed. This many columns are to be formed. Once you frame all these columns, get sum of each of them, that will give you summation of x, summation of y, summation of x square, summation of xy, and summation of x square. Once you get all these values, substitute it in the first and second equation, get it solved, and get value of a and b. After getting value of a and b, you have to substitute it in a standard form. That will generate a linear equation. In this linear equation, if you just substitute different values of x, you will get y calculated. And this y calculated is nothing but your trend values. And that is to be shown in the table. To show it in a table, you have to make one more column named YC. and put all these values against respective year 4.57, 6.74, 8.91, 11.08, 13.25, and 15.42 in that column. And this is how the whole example is done. Is it perfect now? Do you have any questions
Yes.
regarding this method?
No, sir.
Fine enough. As our time is up now, in any case, if you have any question regarding this method, you can text me, then we'll try to solve it off, right? From the next lecture onwards, we will be solving few more examples using the same method, as well as we'll shift on the new method. Or you can say the first method was direct, the second method is shortcut method. Right? We'll be switching over to shortcut method from the next before doing some of the examples. Hope you enjoyed. I'm taking your leave now. Thank you. Thank you for your time. Bye for now.
Thank you, sir. Bye.
Bye.
Thank you.